All right, well, good morning, good afternoon, or good evening, wherever you are in the world. The Global CCS Institute welcomes you back to the second installment of our three-part series, the Carbon Capture and Storage 101 webinars. Again, I'm Matt Bright, the Institute's Senior Advocacy and Communications Advisor based in Washington, D.C., and it's my pleasure to moderate this series. You'll notice that you are all coming in as Matt Bright. Sorry, that is our fault. We sent out the wrong link, so I've never seen this many of myself all in one room at the same time. Apologies for that. No big deal, but do please keep your cameras off and yourselves muted. We will be taking questions at the end of this, and this session will be recorded and posted on our website next week. Please hold your questions until the end of the session. We will get to as many as we can. Use the Q&A function to post your questions. So today we are very, very lucky to have 4 speakers who are all intimately acquainted with the world of CCS infrastructure. CCS infrastructure. If you are wondering what on earth is CCS infrastructure, hopefully in 58 minutes, that's no longer going to be the case. Stay with us. We're going to start off today with Matt Vining. Matt, if you want to turn your camera on, just so folks can see you. Matt is the CEO of Navigator Energy Services, and he's going to discuss their major project plan for the northern Midwest of the US. We're glad to have you, Matt. Welcome. Matt's going to be followed by Dr. Susan Hovorka. She is the Senior Research Scientist at the Bureau of Economic Geology at the University of Texas, Austin. Susan, if you just want to turn on your camera as well, we are glad to have you. And then next we'll have Jean-Philippe Igel, who is the Strategy and Market Developer for the Northern Lights CCS project, to discuss the infrastructure involved in their project in Norway. Jean-Philippe, bienvenue. And finally, we have Ian Hunter, who is the Commercial Manager for Net Zero Teesside and the Northern Endurance Partnership, to talk about carbon storage and transport in the United Kingdom. Ian, glad to have you. Welcome. So I just want to share my screen just for a second to discuss a little bit about the background, infrastructure. What is it? So basic definition in the Oxford Lexical English Dictionary is the basic physical and organizational structures and facilities needed for the operation of a society or enterprise. So when we're thinking about carbon capture, the last 2 weeks ago, we introduced carbon capture projects. There are 66 commercial CCS facilities around the globe. If we're thinking about all these little dots, how do we make this enterprise of carbon capture work? When we think about carbon capture, it's very easy to think of it conceptually as putting a giant bag over any facility that's producing large volumes of CO2. Again, the facility could be producing electricity, cement, steel, biofuels, plastics, all of the things that go into making our life, paper, pulp. Once you have that bag filled up with CO2, you have to do something with the CO2. And that is typically, you're going to bury it far underground, you're going to store it permanently. So how do you get it from that plant, the facility that has the bag over it, to the place where you can store it underground? And that is CCS infrastructure. So we have these beautiful figures. Encourage you to go look on the Global CCS Institute website to think about, look at these figures. Onshore transport, Matt's going to talk a lot about this. Pipelines, big giant pipelines, very thick, can transport CO2. Offshore, we're thinking often about shipping, also pipelines. Our Jean-Philippe and Ian Hunter will certainly discuss these, and then storing it underground. This is where Susan's expertise comes in, thousands of feet below the surface. Just a quick overall note, the Global CCS Institute keeps track of this. CCS is secure. We have 220 million tons of CO2 stored to date. And then a couple final slides just to think about the possibilities for carbon capture and storage infrastructure. This is a figure showing natural gas infrastructure in the US. These are natural gas pipelines, right? There are 300,000 miles of them. This is currently where we're looking at CO2 pipeline infrastructure. There's 5,000 miles of that, and you can see most of the US not really represented here. And so we think, what if we could make this map just a little bit more look like this map? What would it do for climate change? It would certainly add many more dots to this map, we knew. So with that, I'm going to stop sharing and we'll let Matt Vining take over. Matt, you've got the floor. Go for it.
Great, thank you, Matt, and good day to everyone. I'm going to share my screen here, and then we will be mindful of the clock and get things underway. Matt, just double checking here, you can see the presentation on the screen?
Yep, you look great.
Okay, very good. Well, again, good day to everyone. My name is Matt Vining. I'm the founder and CEO of Navigator Energy Services and its newly created affiliate, Navigator CO2 Ventures. We are a private midstream company who constructs various greenfield and brownfield pipeline projects. We're commodity and geography agnostic, which makes us uniquely capable of pursuing projects such as what we've announced here recently. So what are we building? Well, we're endeavoring to build a very substantial CO2 pipeline network that spans multiple states in the Midwest US, principally Iowa, but also with fingers that will extend into Nebraska, South Dakota, Minnesota, and then ultimately to a central sequestration facility in Illinois. We, when entering into this project, conceptually thought about this as, phase one of a multi-phase project. Given the commercial outreach that we've received, I think that assumption has been more concrete in our mind as we see this as really the first step in a multi-step platform to expand even further beyond in the Midwest, going further east, but also further south as the addressable market for carbon capture infrastructure expands.
Matt, could I just, we're having comments come in here now saying that
Sure.
The presenter view, so we need you to show the presenter view, or not just your notes. If you click the display settings, click at the top, the display settings.
Yep. Okay. Yep. And you want me to go to
Matt, if you click at the top of the screen, there's it says show taskbar, display settings, and then slideshow. Yep. In the middle, display settings. If you do that drop down, you can swap.
Yep. Oh, and you want me to go to swap presenter view and slideshow?
That's right.
How's that?
Better. Yeah, perfect. Okay, great.
Okay. Sorry about that. I will pick up where I left off. So we've got this substantial project. It's entirely greenfield. When we announced the project, we had anticipated a design basis to really capture and transport and sequester up to 5 million tons, then expandable up to 8 million tons. Given the outreach that we've received related to the project thus far in the open season process, we're really now focused on a project scope and size that has kind of a base case in that 5 to 8 million ton range, but that is ultimately expandable to 15 million tons. That would contemplate us putting into development multiple sequestration sites in parallel. We will see, we'll talk about the important elements of how we're commercializing the project and where we're at in that process. But as I was saying earlier, we do view this as kind of the first step in a multi-step infrastructure process that reaches multiple emitter markets that we think is a scalable answer over the long term. As I alluded to just a moment ago, we've commenced this what's referred to as a non-binding open season process. This is consistent with FERC precedent and practices and on the natural gas regulatory framework and on the crude oil side of the house. We're essentially, what that means is we're in information collecting mode from potential customers. As is well publicized, Valero is the anchor customer in the project and is underwriting its development. But of course, the addressable market, both in terms of even on the renewable fuel side, but also in alternative industries, represents a very substantial opportunity for our projects, or frankly, any project. Where this ultimately goes is that we will conduct a binding open season process that gives any emitter the opportunity to subscribe for firm capacity, both transportation and sequestration. We expect that process to conclude this summer. We expect it from there to take us around 40 months to permit and construct, and that puts us in a position to begin accepting initial receipts late in 2024, and we expect that process to continue through 2025. So how are we commercializing this? Well, in the pipeline network, I thought the map that Matt showed earlier is very illustrative of as to kind of what the opportunity could be. There's a fair bit of execution and regulatory hurdle between here and there. So what we've adopted are what we think are the best practices and principles that FERC has outlined historically in regulating natural gas pipelines. And even though CO2 is not currently captured under that framework, we've adopted those principles for the purposes of contracting around with our customers today. And what that means is we're going to be operating the pipeline and presenting it to the market as a common carrier. This gives all parties equal access to the pipeline. They can subscribe for long-term capacity. They get a fixed rate associated with that. It's transparent. We will post a tariff. And that checks a couple of big boxes. One, it's a non-discriminatory way to offer what we think is a kind of societal and industry-friendly service. Two, it paves the way for future expansion and integration by providing that framework up front, very similar to the way that they do in the natural gas and crude oil side. And the fee-for-service model that underpins all this is very easy to understand. It does ultimately result in a different economic proposition depending upon who our counterparty is, but it is easy to digest. It's easy to get your arms around, and we think that's why it's been so well received by the market. As I said, we're in the process of offering these services to all of our addressable market constituents, and even those that are a bit outside of our geography and hoping for a phase 2, phase 3 participation. I would say we will get there after the first 1,300 miles, but we're certainly excited about the outreach that we've received thus far. In addition to, there's multiple phases of infrastructure in this value chain. There's the the capture element of this that Matt kind of described as kind of putting a plastic bag over an emission source, the transportation infrastructure in between, and then ultimately the sequestration aspect. The way that we're offering this is that it's entirely fee for service from beginning to end. We as Navigator will install that capture equipment for each of our customers as an offering. That's an electable offering, and then each of them will subscribe for the services in between to get their carbon from the emitter to the destination.
Hey Matt, sorry. Can you just stop sharing for a second, because we're only seeing half of your slide is cut off, and a lot of folks would like to see your previous slide. So. There you go. Okay, can you scroll back too, just to let folks in the audience? Great. Just go back to the one with the CO2 image on it. Yep, perfect. Okay, folks. So just take a look at this again. This is going to be recorded, and we will make sure to put the slides, the PDF of this up on the website, so you could see this quickly. And yeah. Great. Okay, Matt, sorry about that. Now go forward and
no problem.
Thank you.
So we have this. So we've got this commercial framework that we think is consistent with past precedent, both from a regulatory and commercial perspective, and a contracting framework that is consistent with IRS guidelines, specifically as it relates to the 45Q, reporting guidelines that are consistent with, various LCFS frameworks, specifically CARB. And so how does the engineered solution make pipelines specifically a part of the solution? It is not the ultimate solution, but it can be a very scalable option in terms of CCS. And so how do we think about that? Well, the way that we approach this is that everyone's our customer. Even though I have corn stalks, on the first slide and Valero Renewables is our anchor shipper, that is not our addressable market. Our addressable market is everyone who emits CO2. And the reason why we think that this is an attractive approach is because there's an engineered solution by emission type that ultimately can convert a raw stack emission stream that has a component of CO2, but is not entirely CO2, into a common stream pure CO2. So I can design a capture manifest that can accept a raw stack emission from an ethanol or fertilizer plant and convert it into equal properties to that of a natural gas-fired power plant, a steel mill, or a cement manufacturing site. And that's where each of those obviously has different CapEx considerations, and that gets into the whole economic framework. But at the end of the day, that technology and those answers exist. And those can be put to work as part of a broader offering. Again, there's economic considerations that are very important, and we can talk about how the 45Q plays into that. The addressable market that is kind of, I would say, the lightest lift from an infrastructure perspective. Clearly, the ethanol and biodiesel guys, they have a pure form of CO2. They also have an economic driver vis-a-vis the LCFS markets that is a little bit unique to that industry relative to others that are looking purely to the 45Q and maybe future cost avoidance as the economic mousetrap for making a decision to participate or not participate. But I think the bottom line is that, when you think about the scalability of the pipeline, the reason why you could say, oh, Matt, you previously announced, 5 to 8 million metric tons per year, and now you're talking about 15, is, really that's the difference between just taking a 16-inch pipe to a 20-inch pipe and or adding additional horsepower that represents in the whole scheme of things, a marginal incremental capital investment to create that, that order of magnitude capacity that is available for the market. And, with a project of this scale and getting back to the theme of why we think this is really phase one of multiple phases, not just for Navigator, but for industry as a whole, is, you can think about where we go from here. This is a starting place. And we think that we're part of that, being, the first out of the gate or one of the first out of the gate to provide that solution is wonderful, but it is not an end game. And because, you can look at this quadrant and say, boy, there's all sorts of benefits here. It is purely impractical to think that you can capture and sequester CO2 at each of these individual sites on a site-by-site basis. Susan would say, I'm sure, the geology in some cases is not conducive to, sequestration. Even if the CapEx and economics, worked for a localized surface capture solution. And it's impractical or nearly impossible to capture and truck all of this CO2. So we think, again, kind of the scalability of the pipeline model, onshore and offshore, we think makes a lot of sense. In terms of how we interact with our customers and what opportunity this provides to them, lower carbon intensity ultimately we think translates to highest value. And that really doesn't matter which industry you're addressing. In biofuels, you can draw the line between lower carbon intensity and higher LCFS value. But in manufacturing, we're seeing that consumers, both in the public and private sector, they're looking for low carbon products, raw materials, cement, steel, aluminum. And so we think that trend, even though it's just beginning and really in the first and second inning, that's really a long run dynamic. That's not a short run dynamic. And so this project and projects like it really provide an off-ramp or an on-ramp, excuse me, to industries to be able to participate in that narrative and offer their customers something unique that they cannot currently provide. We think that, you know, the geology in the Mount Simon formation, specifically in Illinois, is very conducive for CO2 sequestration. It's very well understood, and in expanding the sequestration viability of that geography, we think that it is really the first step in creating what could be a CO2 hub. And as we acknowledge, you know, our limitation is ultimately the available pore space that we can safely inject into. But ultimately, there's alternative uses where you can create liquidity around, you know, the value proposition associated with permanent sequestration versus alternative uses for carbon, feedstocks, or otherwise. And of course, you know, with a project of this scale, as we're traversing all of these, you know, these different communities and states, there's substantial economic benefits, some permanent, some temporary, you know, where we feel like we can be a good neighbor, a good customer of these communities, you know, while providing, you know, some societal benefit as well. And then this is just a little bit about me. We'll spend the least amount of time on this slide because it's far less interesting. You know, like I said, my name is Matt. You know, we're a smaller privately owned midstream company. BlackRock is our financial sponsor. Valero is our anchor customer. Valero has actually been a customer of Navigator since our inception. We're making lots of new friends on this journey, and look forward to any of your questions and any of that outreach. So thank you for your time. I'll turn it back over to you, Matt.
Great, thanks, Matt. Getting a lot of questions coming in for you for sure. We'll let Susan take it over now to talk about underground storage. Susan, the floor is yours.
Yes. We hear me, we can see the slides.
So we're seeing your background.
Neil, and I didn't click the right share, and now I have to go back and find the right thing. I was so confident.
The dance of the share screen.
Did we get it?
There we are. Beautiful. Okay.
Okay. So I'm pleased to talk about the geologic storage that Matt so elegantly set up. The role of storage is to meet the expectations of these wedge diagrams that you've seen hundreds of. To get those reduced wedges, usually we need to have large volume, permanent storage, and deep saline formations are our target. I'll talk briefly about the use for initiating and augmenting this deep saline formation by use of CO2 for enhanced oil recovery, which reduces oil and stores CO2. So how does this happen? We have a capture facility of your choice. We concentrated ship it, as Matt explained, by pipeline to a selected permitted site. And what's the selected permitted site? It's a place where CO2 can be injected at pressure via wells into pore space at depth below and isolated, hence the word sequester, for potable water. So we have to have a confining system that will limit the CO2 rise. When we inject the CO2, it'll also displace brine. So we also have to contain the brine, and it's stored in this pore system over geologically significant time. So let me show you this very important concept. Let's look in detail. Blow it up in a cartoon. You see now we're down at the millimeters scale. We're seeing the individual sand grains and the CO2 occupying the spaces between the sand grains. Why is this critical? Let me show you. First, we'll get out of cartoon land and see this is a project we're working on down in the middle of the Texas coast. All those yellow zones are the acreage available for storage. Note that they're hundreds of feet thick, they're thousands of feet deep, they're continuous over miles, and they're stacked in many, many zones. So we got the acreage in the subsurface, lots and lots of acreage. Let's zoom in. Here we got a pencil-sized piece of rock imaged in a CT scan on the left. You see the individual sand grain highlighted in red, and then inversed in the yellow, you see the space that's available for storage. And then we do a model to say how much of this space can you actually access with CO2. So we see on the right, you see the CO2 entering the pores at micron scale now. So why is this scale so important? Because what the physics that happens at this capillary dominated scale, it's not intuitive to many of us. We didn't learn it in physics, but it's very important. And rather than explain the diagram on the right, which maybe we don't have time to get into, it's robust, it's elegant, but let me give you a key explanation, which is what goes in won't come out when you're dealing with capillary entry pressure. And so let me give you an allegory. Let's look at something that you are familiar with. Everyone look at your shirt or your tie. You see the porous, you see fibers with little pores between them that allow your clothes to breathe. Okay, let's take your pizza at lunch and drop a little piece of grease on it. What happens? That non-wetting phase fluid, grease, goes into the holes and it won't come out. The only way you get it out is by dry cleaning it, by dissolving it out, right? You can't get it out by pushing, pulling, licking, flushing. No, that's what happens with the CO2. So this capillary size trapping mechanism is very important, and it gives us all the confidence that storage is going to be successful and permanent. So where? Not everywhere. These areas in yellow are the areas in yellow and red are the global exploration zones. The circles in white outline some of the sites that are under study and under large-scale injection now. Our host GCCSI has a global status report. Read more about those white circles. The green circles are other places that could be developed that are not yet on development. Notice that what Matt said about not everywhere works. So some of you are on the East Coast. You see your circle here on the East Coast. You're in a spot that doesn't have it. So you have to go either east or west. As Matt was showing in Iowa, central Iowa, you have to go east. So that's where the infrastructure comes in, as we were hearing about. You can't go straight down from everywhere, but you can access a storage compartment that's sufficient for very large ambition. I jotted down the numbers. There are very large amounts of storage globally that's accessible. So I showed you the upside of storage. Let me talk a little bit about the downside. A lot of work and talk has been invested in risk, and this is because we're going to change a paradigm. We're releasing CO2 to atmosphere. And now we know that there's a communal risk of that, but not so much individual risk for a facility at this moment. So why would they ever, if they change their plan by putting the CO2 underground, what risk do they get? And my slide jumped ahead. One, I'm supposed to show you the positive first. Okay, so you put the CO2 underground, what could happen? I'm gonna go through a quick list of the things we worry about and just this little sketch about how you can, what we know today about managing these risks. You could cause a seismic event, a felt earthquake, or damaging earthquake at surface. You could have the CO2 or the brine escape, where it would damage surface water or return to atmosphere through flaws in the seal. The well itself is the flaw in the seal we worry about the most because we have the most experience about this. I'll give you some information about what we know about flaws in seal through wells. Or we could have a long flow path that lets the CO2 or brine reach the surface. So let's go to seismicity. We could talk about this for days. I'm going to try to give you a snapshot, quick snapshot. This is the axis. This axis shows the pressure and the strength of the rocks. We have depth on the vertical axis. We have pressure on the horizontal axis. The amount of pressure you have to put to push the brine at depth, the water away from, and allow the CO2 to come in is in the blue line. How do we find out what this is in any given situation? We actually do it. We drill a well, we can calculate it from first principles, and then we drill a well and we actually push the brine away and calibrate this curve so we have an accurate measurement of the rate that you can inject CO2. The brown line is the strength of the rock. As you go deeper in the earth, the weight of the rock means that it's harder to break it. So that the space you have to inject into is the space between the blue line and the brown line. You're not allowed in the EPA's underground injection control program to inject such that you continue to frack. You can frack, you do a frack job by using a water hammer to elevate the hydrostatic gradient sufficiently to hit the lithostatic gradient and break the rock. And you'll say, well, Sue, that can't be the whole story because we have seismic events in California where there's no water hammer. Yeah, that's because the earth is in motion. We have plate tectonics. The rocks are under differential stress from, along the San Andreas fault zone, for example, and the rocks themselves can be broken. That also means that in places like Oklahoma, the rocks were under sufficient stress that a small water hammer from water disposal would cause them to break. So what do we do? And we're finding more of these spots. For example, my colleagues are working in the West Texas looking at a similar story about fracking and large volume water disposal and increased risk of seismicity. What do we do? We don't panic because we can make these measurements by actually using the water hammer at small scale in a test bed. You drill your well, you go down and set a packer, you hit it with a water hammer, you see what it takes to break. It's a very straightforward, well-known engineering solution. You have to do it over the area of impact, which is what we're, where we have a learning curve to, we explore a new area, we find out what this is. So good case study. This is from the Mount Simon Formation in Illinois, a little east of where Matt showed you. The injection was down at the number 1 at the depth near the basement. What we see here is a number of seismic events that were measured by placing geophones at depth. They're about 1,000 times less than anything you could feel at the surface. So these are not worrisome, but they're telling you that the rocks in the deep subsurface in this area are fractured and stressed so that you can bump them. You can hit them with a small water hammer and they begin to slip. And so what do? What ADM did is move up to number 2. They went up slightly, got away from the basement so that they attenuate the amount of pressure, differential pressure that's put on this, and they greatly reduce the frequency and magnitude of events. That's what we do. Lots of examples of how to do this. So it's use our good engineering solutions. Don't panic. Use correct engineering and correct regulation. This can be managed, not avoided totally, managed correctly. So what about other leakages? We have a lot of data on this. I listed the data. I'm not going to read it. I especially think you might like to look at, for example, the experience from the regulator in Texas, where we have an online inventory. If you Google Railroad Commission blowout, you can read about every blowout. Most of the time, people fixate and anchor on the Macondo and Aliso Canyon, which are the very destructive end members. Those are not typical. It's very important to understand this is a distribution. And those distributions were caused by well-known failures that, compliance and failure to use best practices cause these events, so that this is a management problem. We can also find out what the consequences of mismanagement are by doing controlled release. What would happen if CO2 leaked out to air, water, soil, ocean? What we get is small but detectable impacts. We don't get massive damage. Want more about it? Here's a whole bunch of places where this is, clusters of researchers have had splendid times putting CO2 into various environments and looking for the impacts and then measuring and quantifying. This should build your confidence. Brief digression to CO2 EOR. It's useful because it has it's familiar, it's regulatorily mature, it's got positive economic benefit. What you have is a case I told you that when you get your grease on your shirt and it went into the porous media, well, that's where oil is. We have lots of oil that's stuck in the subsurface and it won't move to production wells without. So we need to add dry cleaning fluid. That's CO2. It's miscible with the oil. It causes technically viscosity decrease, volume increase, causes the CO2 to be able to migrate to production wells. So you can bump production back up. Important thing is that CO2 EOR is a closed loop system. Let me show you. Yes, your reducing CO2 emissions, you're capturing, putting it down a well, just as we did in saline storage, okay? But then here's the worry point. It's coming back up. To get the oil back up, you also get CO2 out. You send the oil to market, you have to deal with this in the life cycle. We could talk about this endlessly. You do have to, the oil comes out, yep, has carbon in it, yep, deal with it. But the important thing I want to tell you is that the CO2 is recycled, and this recycle is very effective. We've done surveillance on this with commercial EOR projects. All the captured CO2 remains isolated from the atmosphere. Very important to realize this key element about EOR. So it's not that CO2 is, you can worry about the oil, but don't worry so much about the CO2, assuming that the company is working under regulations under the UIC program. So we've had 50 years of safe and effective injection of all kinds. There's a lot of things you can look at to help you build confidence through all kinds of injection. To conclude, I want to tell you these things. The status of geologic storage and deep saline formations and EOR is mature. It's successfully underway. It's ready for larger scale implementation. The main challenge is convincing key stakeholders that this is true. So I am at your disposal to help you become believers that this first statement is true. Let me know what you need to know in the question period. The capacity is very large. It's not a problem. We don't have enough space underground, but it may not be where you are or where you want it, as we saw in we have to build the infrastructure to get the CO2 where it can safely go, where storage is effective. Failure is rare. The consequences are quite ordinary. The risk is manageable. So this is some moderate statement that you can't be foolhardy, but you shouldn't be so anxious you can't proceed. Let me flash my contact in case you want to contact me beyond the question and answer period. And that's it, Matt.
Great. Okay. Well, thank you, Susan. That was really fascinating. Water hammers, so many things, new concepts coming in for me. Fascinating. We are definitely running a little bit behind, but Jean-Philippe, take it away, please.
Yes. Good morning, good afternoon, good evening. Thanks, Matt. So let me just share my screen and presentation. It should come your way. All right, so I'm Jean-Philippe Yegel. I'm the Strategy and Market Director for the Northern Lights joint venture company. I'm very happy to present today. So let me give you a few words about Northern Lights, a project and joint venture. So I'm located in Norway. Northern Lights is a project based in Norway, part actually of a first commercial CCS chain involving multiple emitters. So on the Northern Lights joint venture side, our perimeter is to offer and provide a service of shipping and storage to our customers, industrials located in Norway and in Europe and willing to decarbonize their activities. So we are proposing and offering a flexible shipping solution. So developing ships which will allow to accommodate volumes from multiple emitters, multiple locations, and allowing, as a matter of fact, the decoupling of emitter location on one side and storage location on the other side. And as Suzanne just showed, the fact that storage capacity are unevenly distributed worldwide, we are offering, thanks to shipping, a solution allowing to decouple where the CO2 is being emitted and where we can store it. So you see on the right side, upper right side, the schematic where you start with our customers capturing and liquefying their emission, and us coming their way with our ships to transport those liquefied CO2 emissions up to a terminal, an onshore terminal that we are currently building in Bergen area, so west of Norway, and you see it on the map below, the Naturgasparken. So we are building a terminal at a capacity of up to 1.5 million tons per annum. And this is namely an offloading and temporary storage terminal location. And from this place, a pipeline will go offshore, transporting the liquefied emissions to an offshore storage location, 100 kilometers away from the coast. A pipeline already dimensioned at 5 MTPA, and then bringing those emissions to injector wells down to a saline aquifer where the CO2 volumes will be permanently stored. So our project is considered today as a phased development project. The phase 1 includes, as I said, capacity to transport, inject and store up to 1.5 million tons per annum. And we are contemplating the possibility to increase capacity up to 5 MTPA in another phase 2 of the project. What we see with this kind of initiative, and especially here in Norway, it's really an incentive to launch a European CCS market, thanks to the shipping flexible solution, but as well thanks to the Norwegian state, who has provided and has agreed to provide support on this project during 13 years. In exchange, actually, for up to 0.8 million tons per annum capacity reservation. So basically, the Norwegian state is helping kickstarting, this initiative, this project, and will provide support to us and to 2 industrial located near Oslo, so Fortum and Norcem. Those 2 industrial will capture and liquefy the emissions, and we will commit to actually reserve capacity for them. So 0.8 MTPA compared to 1.5 capacity in our phase 1. The delta, actually the available capacity, is what we will try to source from the market and to sell to industrials, and what will constitute actually our future revenue base. So CO2 storage, I think Suzanne covered quite a lot of aspects of this thematic, but for us really a permanent CO2 geological storage is seen as a return to the origins. And in that space, we are quite advanced on our side. We have been awarded an exploitation license, number 1, so the first one on the Norwegian continental shelf, called Aurora. We got it in January 2019, and it's covering a saline aquifer located south of a giant gas field named Troll, and so namely 3,000 meters below the seabed in a formation called Johansen. This storage complex has an expected capacity of a minimum of 100 million tons. In order to unrisk this virgin area, we have drilled already an appraisal well in March last year, 2020. And this appraisal well has proven high quality sandstones, but as well as sealing cap rock and a good hydrostatic pressure regime. So we are quite confident that this storage complex has enough capacity, has the good characteristics, and is actually safe for storage. As well here, this operation to store CO2 underground is for us safe, well known. In Norway, it's been now 25 years that CO2 is being injected and stored in the Sleipner field since 1996, and in Snøhvit field since 2008. So there is a strong knowledge and expertise in that domain. And we will indeed put in place all the monitoring and injection control measures as part of our project to mitigate all and ensure the safety during operations. So related to CCS in Europe, a bit of overview in that space. So CCS today has picked up in Europe. There is a real momentum. It is seen as an essential technology to reach the Europe carbon neutrality ambition by 2050, and a necessary tool to meet the Paris Agreement's targets. So here I'm quoting the International Energy Agency, sustainable development scenario to stay below 2 degrees Celsius. And there we see really that CCS is needed and is needed to grow at a pace analog almost as the one of the oil and gas industry at its beginning. Time 20 by 2030, time 80 by 2040. So really a need to use CCS as a tool to meet the Paris Agreement. We see CCS at the core of the carbon neutrality virtuous circle, allowing to capture and store residual CO2 emissions emitted by hard to abate industries like cement, steel, refining, chemicals, and so on, but also allowing to generate low carbon power from gas. And as well to remove carbon from the atmosphere, so-called negative emissions, through bioenergy with CCS, the BECCS, and direct air capture initiatives. This technology is fully part of the European climate neutral ambition. Like I said, the momentum is picking up. In Europe today, there is a lot of initiatives from the regulatory side being launched. European Green Deal, the first European climate law, but as well, this ambition to be carbon neutral by 2050 is embedded into also the member states' national strategies. So in Denmark, in the Netherlands, in Norway, in France, in Germany. So different ambition to reduce emissions. And along that way, CCS is really one of the tool that is promoted. So for us in Northern Lights, what we see is what we believe is really that we are at the dawn of a new industry. And Northern Lights as a project, but as well as a company, is a front runner in Europe. We are the first project, CCS project, to went through a final investment decision last year, as well as getting the Norwegian Parliament ratification for support. And this year, back in March, we incorporated the Northern Lights joint venture company. So it's a company with 3 owners, Equinor, Norwegian company, Shell, and Total. So this company, Northern Lights joint venture, is the first company worldwide to deliver CO2 shipping and storage as a service. And we are now building, so you can see in the middle that building, the construction works have started on our terminal site. And that will continue for the next 3 years, with the start of injection scheduled by mid-2024. So what will be needed for us to expand, but as well for CCS as a whole in Europe and in the world to pick up further, really is to first to rely on subsidies and carbon pricing as short-term enablers. So that we see that context in Europe, like I said, quite picking up. And those 2 pillars are really necessary to bridge the gap between, on one side, the price to emit for an industrial, but on the other side, the cost to decarbonize. I just put here in the middle that, for example, on Northern Lights phase 1, the full chain costs, including capture, can go above $200 per ton, while ETS, which is the emission trading scheme in Europe, has increased a lot, but is, and I think we reached a record high this week of $60 per ton. But still, there is a gap to be bridged. And on the short term, subsidies and carbon pricing will be really the two tools. But then the next levels to create value, which we are working on as well, together with the states, so as a private and public partnerships, are first state policies that will allow to link CCS and emission targets, so storage certificates, fiscal incentives, different measures from policy measures that will create a proper framework for CCS to grow. And then the second level will be added value for zero carbon products, and that green steel, green cement. There is a room here to create as well value and promote this decarbonization activities. On the full right, you see a map here, just to show that so the European Commission is quite involved in the CCS space. And Northern Lights, we got a label called Project of Common Interest. That is really putting ourselves in the middle of a future European CCS ecosystem, where we are discussing with several emitters spread all over the North Sea and the Baltic Sea that may converge towards our terminal. We are also looking at discussing with, collaboration with other storage projects, for backup alternatives. So really the idea is to create a full ecosystem around CCS in Europe. Thank you for your time and attention, and I encourage you to check out our newly established website.
Great. Thank you, Jean-Philippe. Ian, sorry, we short-shifted you on the time, and I apologize for that, but take it over.
The curse of the last presenter. Thanks. Thank you, everyone, for inviting me here. So I'm Ian Hunter. I'm the commercial manager of the Net Zero Teesside and Northern Endurance projects. Matt, are you okay to present the pack, if that's okay? So I'll give a bit of background on CCS in the UK, and I'll talk about our project and the infrastructure for transporting and storing CO2 across the UK. So I think the first one we've got, if we just let Matt get the pack up. Brilliant, thanks, Matt. So the first slide down just gives some of the key roles for CCS. So you've got industry, which can have CO2 captured directly, power, where you can capture CO2 after combustion using gas or coal or biomass, for example. And then you've got blue hydrogen, where you're converting natural gas to hydrogen, and the CO2 can be captured. And in all of those scenarios, you'd obviously need to transport and store CO2, so you can do that by pipeline or by ship. This just sort of lays out some of the key uses for CO2 or roles for CCS. If you flick down one, Matt, the UK's approach to this has been really focused around industrial clusters. Sorry, Matt, can you just flick down? Thanks. So there was a law put in place in 2019 in which the whole country will have to be net zero by 2050. Back up one. That's it.
This is all.
That's it. Perfect, Matt.
Yeah, this is all I have. These are your slides?
Yep. Do you not have more below that? Yeah, that's it. That's fine. Yeah, you're okay.
Yeah, sorry, this is all I have. I'm advancing your slides.
So just, yeah, stay there. I'll give you a shout. So
Right.
In November, we had a 10-point plan published by the government in the UK outlining the plans for the next decade. So the aim is to develop 4 CCS clusters based around industrial centres, with 2 starting up in the mid-2020s and 2 more by 2030, with an initial aim of 10 million tonnes per year by 2030. But we just had our independent carbon budget updated, which actually increased those sort of targets, suggesting that we'll need to capture more than 20 million tonnes by 2030. And over 100 by 2050. So fairly ambitious targets for a country on the scale of the UK. If you can flip down one, Matt.
Right here?
That's it, yeah. So the UK's got a number of industrial clusters. So back up one. You were on it. That's it. So we've got Scotland in the north. We've got projects in the northwest of England based around hydrogen, down in South Wales, which has a steel industry. And then the projects we're looking at are on the east coast facing the North Sea. So we've got Teesside with gas, bioenergy, industry and hydrogen. And further down the coast, you've got the Humber, which is the biggest industrial region in the UK, again, with a range of hydrogen, bioenergy, gas, power and industrial CO2. And we're focusing here on the transportation and storage system that serves those 2 clusters with the ability to store CO2 in the southern North Sea. If you go down just the one, Matt. So you can see here, as you look out from the east coast of the UK, you're looking at the southern North Sea, which is the heart of the UK's offshore gas industry. Across the water is Norway, where you've got the Northern Lights projects. And you can see why this is an attractive place to do CCS. You've got 2 of the biggest clusters in the UK, Middlesbrough and Teesside, and then Humber, which are about 60 miles apart. And we've got the ability to tie both of those clusters together into the Endurance Store, which is probably the biggest appraised store in Europe, with about 500 million tonnes of storage capacity ready to go. So we'll be planning to develop that and ultimately to build out further into the southern North Sea, where there's similar sorts of stores and depleted gas fields. The store itself is a saline aquifer, so it's we'll be injecting CO2 into a geological formation which contains water that's different from an old oil and gas field, which is an alternative type of store. If you can just flip down one more, Matt, we're going to zoom in a bit on Teesside, which is just one of those 2 clusters. One of the things about Teesside is it's incredibly compact. So you can see it's about 14 kilometers, that's about 9 miles across the whole area. And within that, you've got a huge range of different types of emissions. You've got different types of power, gas power, energy from waste, biomass. You've got chemicals, hydrogen production. So you've got all sorts in here and the ability to really capture significant economies of scale, which is one of the key reasons why we chose Teesside. We're looking at an initial capacity of about 4 to 6 million tonnes from Teesside, with a pipeline sized at 10 million tonnes to allow us to build out rapidly with a startup in 2026. Just briefly on the power station that we've got there, the plan is for a dispatchable gas power station that can respond to market demand, like a typical gas power plant. That would be the first in the world to do that at that scale. And it's really important for the UK, where we've got a huge amount of intermittent renewable energy, especially offshore wind. And that allows you to fill the gaps in the market that are needed when you've got something like wind, which can't produce 100% of the time. And as I said, the offshore will be shared with Humber. So when you put those 2 clusters together, we're looking at a combined storage capacity of up to 27 million tonnes per year. In the interest of time, Matt, I might just flick down to the bottom slide. Have you got the pictures? If you go down 2.
This one?
There's one more down with pictures on it, yeah. So I just wanted to maybe finish off by tying it back to what it means locally. So school children in the UK are always told about the role of their local town or city in the Industrial Revolution. And people have got a real pride for their industrial heritage in their towns. So you can see here some pictures. Teesside had the world's first public railway with a steam engine back in 1825. It became a huge steel producing area. So the Tees River was known as the Steel River. It had 91 blast furnaces along the length of it, along just a sort of 7 or 8 mile distance. You can see the Tees Transporter Bridge here, which is an iconic landmark for the area. It carries a gondola which can transport people and vehicles over the river, and it was built back in the early part of the last century to allow the industrial shipping to continue to pass underneath. The eagle-eyed amongst you might have noticed at the bottom left is not a picture of rainy northern England. So this is a Sydney Harbour Bridge, which is one of many buildings all around the world built with Teesside steel. You've also got the Canary Wharf, the big tower in the centre of the UK's financial district. Our national football stadium at Wembley, the big arch across that, Teesside steel. The Freedom Tower being built in New York's got specialist beams from Teesside, so it's a real sort of pride for the area. And the bottom right, you can see the last major furnace in Teesside. And the really sad thing is that closed just a few years ago. So it's a huge blow for a region that prides itself on that history. Our project's going to be developed on the site of that decommissioned steel plant. So, you know, when we went there for a consultation, we had all of our preparation around questions around the environment and safety, visual impact, and there was no questions about that. It was just jobs. You know, how many jobs? When are the jobs coming? You know, can I work there? So it really links it back to the, you know, this is not just about reducing emissions, it's about injecting a bit of pride back into our industrial heartlands. It's a message which we find to be much more powerful with the public. And it's something which also probably translates quite well across the different countries, you know, US, UK, and all the other countries that are trying to develop CCS. So I'll leave it there. Did it as quick as I could, Matt. I hope that was.
That was beautiful. Thank you, everybody. Thank you to our loyal audience. Apologies, we've had some technical difficulties today. We were humans and didn't get this off 100%. But we will put the presentation up on our website as long with the slides. We will try to get to. We've been trying to answer Q&A. We will try to get you the Q&A to the right appropriate people. Please come back for our next and final webinar 2 weeks from today. Same time, we're going to be discussing CCS policy. Thank you to our speakers. You were all really excellent. We ran into a wonderful problem of just having so much wonderful information to share. We'll have you back. Thank you, everybody. See you in a couple weeks.